Our universe is a constantly evolving and dynamic system with countless stars, galaxies, black holes, and other fascinating cosmic phenomena moving around and affecting the space around them. Over extremely long timescales, these processes wind up fundamentally changing the universe and what it's made up of. So, with this in mind, what will happen to the universe in the extremely distant future? Now, before we answer this question, I'd appreciate you like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Alright, so before we get into what's going to happen to the universe, we need to understand a few things about the universe itself. For one, it is actually expanding, with galaxies slowly getting further and further apart from each other and will eventually be unable to reach or even see each other unless they are gravitationally bound to each other. This expansion has actually been accelerating over the past few billion years, with galaxies getting further and further apart at a faster rate over time. We don't know exactly why this acceleration is happening, but it is theorized that a mysterious force known as dark energy is powering it. Because dark energy is so mysterious, we don't really know anything about its properties or mechanics. So what happens to the universe is in part determined by its properties and how they might change over extreme amounts of time. Secondly, there are a variety of major paths that the universe could take in the future, from collapsing in and on itself to a reverse Big Bang to ripping itself apart so completely that even individual atoms are torn apart. However, this video will focus on the most likely outcome, which details that the universe continues to expand infinitely, but said expansion is not strong enough to overcome gravitationally bound structures. So, with all that out of the way, let's get started on this journey into deep time. As of this moment, the universe is approximately 13.8 billion years old, and is currently in what's known as the stelliferous era, which is basically the era that is dominated by stars. As we speak, stars in the universe are condensing from vast clouds of hydrogen and helium gas and having their cores ignite nuclear fusion that keeps them running for billions of years until they finally run out of hydrogen to burn and die out in a variety of different ways. The key thing to note is that when a star dies, most of its material is returned to interstellar space to later form new stars, but a portion of it is kept inside a degenerate core that isn't available for future use, whether it be a white dwarf, neutron star, or black hole. As a result, over long periods of time, the amount of available hydrogen and helium for new stars to form is slowly dwindling, which will result in gradually decreasing rates of star formation. Eventually, the universe will reach a point where it's impossible for stars to form straight out of interstellar space at all, a point which it will likely reach in at most 100 trillion years. Stars will burn for a few trillion years after this point, since red dwarfs, which are the longest lived stars, are capable of burning hydrogen in their cores for tens of trillions of years themselves. Over this vast time frame, the universe will continue to expand, and in about 2 trillion years, it is estimated that anything beyond our local group of galaxies, which is composed of about 40 galaxies in 10 million light year radius, will be completely undetectable, with the local group itself having coalesced into a single massive galaxy hundreds of thousands of light years across. Beyond this point, any future civilization will presume their galaxy to be the only one in existence, with only endless blackness beyond, and in a way, they'd be right. In addition, they would be unable to study the Big Bang or the universe's expansion as a whole. Finally, after about 110 trillion years, we reach the point where the last star formed from interstellar space dies out, and the universe enters another new phase, known as the degenerate era. In this period, the only large objects will be cold, dead objects like white dwarfs, neutron stars, black holes, failed stars known as brown dwarfs, and planets. During this period, the main action comes from these objects colliding with each other by chance, creating objects that are a little bit more interesting. For example, two neutron stars or large white dwarfs could collide and create a supernova that expels some material into interstellar space and lights up the sky for a few months. Two less massive white dwarfs could collide and create a small star that can in some cases burn for a few hundred billion years, and a very massive brown dwarf could gain just enough mass from the remnants of the interstellar medium to ignite nuclear fusion. Over the large expanse of a galaxy, this will amount to a few hundred stars active in emitting heat, light, and energy, which will continue for a few quintillion years. However, thanks to some very complicated orbital dynamics that I cannot explain here, mainly because I barely even know how it happens, most stellar remnants will either be ejected from a galaxy or fall into its central supermassive black hole. and any binary star systems and planetary systems will have fallen apart as well. As a result, given the universe's continued expansion, we now reach a point where only solitary objects remain in the universe, which includes our usual suspects of white dwarfs, neutron stars, black holes, and rogue planets. By this point, all of these objects will have radiated away all of their heat and have become as cold as the background temperature of the universe, which itself is now only a tiny fraction of a degree above absolute zero. But the degenerate era still isn't over. A hotly debated topic when discussing the future of the universe is whether or not protons decay over unfathomable amounts of time. Most models of particle physics don't indicate that protons should ever decay, as there is no large particle that's lighter than it. However, if they do decay, it is estimated to be on the half-life of anywhere between 10 to the 34 and 10 to the 40 years, which is 1 followed by 40 zeros. The reason this is important is because the proton is crucial for matter itself. So if the proton disappears, matter itself disintegrates as well. This would eventually result in the disappearance of all objects made of matter in the universe, including our white dwarfs, neutron stars, and rogue planets. So, with black holes immune to the decay of matter, are they the sole rulers of a cold and desolate universe for eternity? Not quite. This new era, the black hole era, is dominated by them, but they do not live forever. Over absolutely mind-boggling amounts of time, these black holes slowly evaporate through what's known as Hawking radiation, which is another weird quirk of quantum mechanics in the edge of a black hole. This process happens really, really slowly, with the lifespan of a black hole the mass of the sun estimated to be 10 to 26 times longer than the lifespan of a proton. The true giants, supermassive black holes, would take even longer to evaporate away, on the scale of a Google years, which is 10 followed by 100 zeros. However, these black holes wouldn't quietly fade away into the darkness. Instead, as they shrink, they emit more and more energy, which in their final moments would amount to an orbit light as bright as a star. These specks of light will be the last light to ever shine in the universe, and one day, the last supermassive black hole will undergo this process, emitting a final burst of light along with quite a few subatomic particles. So, what happens after this point? Well, safe to say, not much. At this point, the only stuff left in the whole universe is stray photons, electrons, positrons, and other extremely light subatomic particles. Collision between these particles would happen for a little bit, giving off trace amounts of energy, but the universe is still expanding, so eventually it will be impossible for a particle to even come close to another particle. When this happens, the universe will have reached heat death, which is a final energy state where absolutely nothing new happens, and the observable universe is an endless emptiness, save for one stray electron that is careening towards no destination, and with nothing happening, time becomes utterly meaningless. Kind of depressing, right? Well, there is some hope. Due to yet another quirk of quantum mechanics, there will continue to be small quantum fluctuations amongst the endless darkness, and given enough time, these fluctuations may happen in such a way to ignite a new Big Bang, creating a whole new universe as part of an endless cycle. However, the timescales that are likely needed for this stuff to happen are so massive that there isn't enough storage space in the world to represent the number of all the zeros laid out. Regardless, if something is possible, given infinite time, it can and will happen. And on that note, that's all I have to say on what will happen to the universe for now. Once again, there are several other paths the universe can take in the distant future, and they hinge on everything from the shape of the universe, the properties of dark energy, and whether or not protons decay. If you want me to make another video on these possibilities, let me know in the comments. And as always, I would appreciate if you like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Thanks and have a great day.